Okay, now we're going to get into the good stuff. So I'm just going to focus on this geometric sequence mostly. To go from a 2 to a 4, if it's geometric, it's growing by multiplication, so that, not by 4. That was last time. We times it by 2. So this is going to be also doubled, and this is going to be doubled, and this is going to be doubled. Did I get off? So this is going to be 8, this is going to be 16, 32. Okay, now the in-between is what's intriguing on this one. So here's my question. What number, and because it's all times, I got to use times. What number times itself is going to give me 2? Because I'm timesing by 2, but not every single time. I'm timesing by 2 every other time. So my question is, what am I multiplying by every single time? So the addition is easy. Look at this. This is up 2. So this is going to be 6, 8, 10. Every other time is going to be up 2. But in between, it's not really growing 2 every time. It's growing 2 every other time. What number, because it's all plus, this must be plus. What number plus is going to give you 2? What number plus itself is going to give you 2? This is 1 and 1. So this is 3, 5, 7, 9, 11. That's growing by 1 every single time. Okay, the question I'm asking you here, what number times itself is 2? And the answer is the square root of 2. Because the square root of 2 times the square root of 2 is going to be 2. It's going to be the square root of 4, and the square root of 4 is just 2. So I'm timesing every single time. I'm timesing by square root of 2. So this is going to be 2 times square root of 2. 2 times the square root of 2. Check this out. 2 times the square root of 2 times the square root of 2 is equal to 2 times the square root of 4, which is equal to 2 times 2, which is equal to 4. 4 times the square root of 2 is going to be 4 times the square root of 2. 4 times the square root of 2 times the square root of 2 is going to be 4 times the square root of 4, which is going to be 4 times 2, which is going to be 8. 8 times the square root of 2. So it's pretty cool. Every time you're multiplying by the square root of 2. So the idea is this. If you are multiplying 2 cubed, that means 2 is your multiplier. You're multiplying by 2 times 2 times 2. When it is a whole number, that is repeated multiplication. But if you want to times by 2 and you want to cut that in half, this is what it looks like. 2 to the 1/2. And that is equal to the square root of 2. So this right here is the takeaway. This is what you got to understand. If you're going to cut multiplication in half, that is the exact same thing as 2 to the 1/2. And those are always going to be square roots. If you cut it in thirds, it's going to be cube roots. Cut it in fourths, it's going to be fourth roots. So let's look at some of these. Let's look at pause, I guess. Let's do some of these first. Okay, your function. You've got a function, and it's 2x minus 7. It looks like it's linear. They want you to find the answer. So this is the answer, and this is x. X is right here. So this is the exact same thing as y equals 2x minus 7. So this is a function notation for y. They're the same thing. But they want to find the answer when x is negative 3. So you've got your x and you've got your f of x. So x right here, you're going to plug in negative 3. Negative 3, and if I plug it in, negative 3 times 2 is negative 6. Negative 6 minus 7 is negative 13. So my answer is negative 13. When I plug in negative 3, I get negative 13. Okay, now look, they give you the answer. F of x is 21. They're giving you the y, and they want to know what the x is. So take 21, plug it in for y. 21 equals 2x minus 7. Solve for x. Plus 7, plus 7. 28 equals 2x. Divide by 2, divide by 2. X must be 14. If you plug 14 in, does it give you 21? Yes, it does. Okay, now 1/2, that's going in for the x. So plug in 0.5. 0.5 times 2. Half of 2 is 1. 1 minus 7 is a negative 6. Okay, let's look at 20. 20 is an exponential function. They want the same thing. So if I've got an x and a y, this is my x. Plug a -4 in for x. What the heck is 3 to the -4 times 2? So negative exponents. I'm going to take this 3 to the -4 and it's going to be 1 over 3 to the 4. And that 2 stays on top. So I'm going to have this, I'm going to have 2 over whatever 3 to the 4th is. So my calculator, 3 times 3 is 9 times 3 is 27. Is that 81? 2 over 81. Okay, B. The answer is 162, and they want to know the x, so this is a tough one. 162 is equal to 3 to the x times 2. Okay, I'm going to ditch the 2. Divide by 2, divide by 2. What's half of 162? 81 is equal to 3 to the x. And I think we just did this. 3 to the 4th is 81. So 3 to the 4th is 81, so that means x has to be 4. So x has to be 4. So if you plug 4 in, you're going to get 162 out. Okay, last one. Plug 1/2 in for x. So if you plug 1/2 in for x, 3 to the 1/2 times 2. Okay, I'm timesing by 3 and I'm cutting it in half, so that's going to be the same thing as square root of 3 times 2. So my answer is going to be 2 times the square root of 3. Alright. Okay, here's where we want to start practicing. Here's what you got to know. If you have x to the a divided by b, that is the same thing as x radical a b. Or x radical, your b is going to go here as your index, and your a, either way. So 3 to the 1/6 is going to be the 6th root of 3. Number 2, 8 to the 1/5 is, you're cutting it into fifths, so it's going to be the 5th root of 8. Number 3 is going to be 12 to the cube root. Okay, now hold on. This one, 12 is kind of a big number. I got two 12s. So look at this. 12 is going to be a 4 and a 3. That's going to be a 2 and a 2 and a 3. So if I rewrite 12, it's going to be 2 squared times 3. But I have two 12s, so that's going to be 2 squared times 3. So it's really going to be the cube root of 2 to the 4th times 3 squared. Okay, now because it's a cube root's going to undo any cubes, and I have a cube right in here. So my final answer, cube root of 2 to the 4th, 1 2 comes out, and a 2 stays in, and then a 2 times 3 squared is 2 times 9, so 2 times cube root of 18. If you change that to a radical, look at 4, s cubed to the 3/5, so that's going to be s cubed to the 3/5. There we go. So you got s cubed cubed. So this is the same thing as the 5th root of s to the 9th. And a 5th root is going to undo any powers of 5. And this is the same exact thing as the 5th root of s to the 5th times s to the 4th. I got 9 s's. So this 5th root is going to undo this 5th power. So I'm going to have s on the outside, on the inside, s to the 4th. But you got to have the index. There we go. Okay, 5, 6, 7, and 8. Let's look at 5. Square root of 51. Morph it to exponents. That's going to be 51 to the 1/2. 51. There's no way you. I think 51's prime. There's no squares in 51. 37. Cube root of 37 is the same thing as 37 to the 1/3. Okay, this is a good one. Let's play around. It's going to be 15 to the 3/4. But I wonder, is there anything that's going to come out of here? 15 is a 3 and a 5. I don't think so. So it's going to be the fourth root. If you got 3 and a 5 is 15, but you have 3 15s, that's going to be 3 3s and 3 5s. But nothing is going to be undone because the fourth root only undoes powers of 4. So that's my answer. Okay, 8 is a little different because there's 3 elements, there's 3 factors. So let's do them one at a time. This is going to be 6 to the 1/3, x to the 1/3, and y to the 2/3. Okay. Ah, man, we're gonna run out of time. So let's just do a few of these. 32 to 1/5. Okay, let's bust up 32. 32 is really 8 times 4. That is 2 times 2 times 2, and a 4 is 2 times 2. So look at this. 32. Always swap out your numbers. The trick is swap out your numbers for the prime factorization. So this is 2 to the 5th to the 1/5. This is really what you want to look at. When you raise a power to a power, you multiply them. So this is going to be 2. 5 multiplied by 1/5. Multiply your tops. This is going to be 2 to the 5/5. So your answer is just 2 to the 1. Okay. Not too bad. Number 11. Negative. You can never have a negative exponent. So I'm going to take that 27 to the 1/3 down there. Okay, now let's bust up 27. 27 is 9 times 3. Check this out. This is 1 over. Is that 3 3s is 27? Always trade your number for the prime factorization. So 3 cubed to the 1/3 is going to be 3 to the 3 times 1/3. It's going to be 3 to the 3/3. It's going to be 3 to the 1. So my answer is 1 over 3. Okay. Let's skip a couple. 17. When you're times and powers, you add the exponents. So this is c to the 12/5, add 3/5. This is c to the 15/5, or c cubed. Times them on 19, so it's going to be q to the 3 times a half. It's going to be q to the 3 halves. Okay, 21's a good one. Can never have a negative exponent. So I'm going to take it to the bottom. 1 over x to the 6/11. And just like it is unacceptable to leave irrational numbers in the denominator, you cannot leave. That's really an irrational number, because this is the exact same thing as 1 over 2 to the 1/2. So you can never have radicals or exponents that are fractions in the bottom. So I'm going to times it by a fancy 1. I'm going to times the top and bottom by x to the 5/11. 5/11 because I know that I'm going to add these exponents together if I'm timesing the powers. So the top is going to be this times this. Top is going to be x to the 5/11. The bottom is going to be x to the 6/11. Add 5/11, and that is 11/11. So my final answer is x to the 5/11 on top. On bottom, x to the 1, and you don't even need to write the 1. It's just going to be 11/11. Okay, let's look at 25 and call it good. The 12th root of 64. 64, always swap it out. It's going to be 8 times 8, so it's going to be 2, 2, 2, 2, 2, 2. So it's going to be the 12th root of 2 to the 6th. And that is actually the same thing as 2 to the 6/12, which is 2 to the 1/2, which is the square root of 2. So you can simplify these just like you can these. That's really 6/12. So change it to a half. Divide them both by 6. Okay. What's legit about the left one and bad about the right? The left one does exist on our number line. It exists right here at -2. So I'm asking you, what number times itself 3 times is a -8? So something times its exact self 3 times, and your answer has to be -8. -2 times -2, that's a +4, times -2 is negative 8. So there we go. This is what I'm asking you in English, and that does exist on our number line, and it's right there, negative 2. The English, what number times itself twice is negative 8. So the index is 2, it's a square root. And this is impossible because there is no number times this exact self that's going to give you negative 8. Because a positive times a positive is a positive, or a negative times a negative is a positive. So this does not exist on our number line. This has no existence on our number line. But it does on an imaginary number line. So, and it exists right here on the imaginaries. Square root of a negative 8 is the same thing as the square root of a negative 1 times the square root of 8. Square root of negative 1 is the imaginary. Square root of 8 is 2 times the square root of 2. So it's an imaginary times 2 times the square root of 2. So it's 2 imaginaries times the square root of 2. So that's somewhere, who knows where that is. 2 imaginaries. 3 imaginaries. 2 imaginaries times the square root of 2. What's 2 times the square root of 2? 2 times the square root of 2. So it's like 2.82. So somewhere right here is 2 imaginaries times the square root of 2. So anytime you have an even index and you're trying to get a negative answer, and that's impossible because you can never multiply an even amount and end up with a negative outcome. You'll always end up with a positive outcome. But if you multiply an odd amount, it is totally legal to end up with a negative outcome, because a negative times a negative times a negative is negative. So here we go. What you need to know about imaginaries is 2 things. The imaginary number is the square root of a negative 1. But if you have an imaginary times an imaginary, that actually is a real. These 2 things, if you remember these 2 things, it's easy. So this, times your numbers. 3 times negative 2 is negative 6. I times I is I squared. I squared is negative 1. Negative 1 times 6 is a positive 6. Times 5i is going to be 30i. 6, 11, I to the 11th. How many squares is in I to the 11th? I squared, I know that 5 squares is 10 times I to the 1. There are 11 i's. I squared is negative 1. Negative 1 to the 5th power times I is a negative 1 times I, which is a negative I. Number 7, how many squares are in 65? I know that squares, there are 32 squares in 64. 65 is going to be 1 extra. I squared is a negative 1. What's negative 1? 32 times. That's a positive 1. Positive 1 times I is just I. Okay, 8. Addition. You only add like terms. Hey, hold on. Shut those. Don't let anyone grab iPads. Don't let anybody grab iPads. 7 add a negative 12 is going to be a negative 5. A negative 8i, negative 4i is negative 12i. So, combine your like terms, that's it. Last one. Let's times them. I'm not going to do them all. 3, this is distributed. You multiply just like you would your real numbers. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is plus 12i. 4i times negative 4i is a negative 16i squared. Combine these are like terms, that's 0, so you got 9. I squared is negative 1. Negative 1 times negative 16 is a positive 16. Your answer is 25. Okay, 15. You cannot have an imaginary on the bottom, just like you cannot have an irrational. So you're going to multiply by a clever 1, just like you would your square roots. Times this by I over I. Okay, your bottom is going to be 3i times I. That's going to be 3i squared, which is a negative 3. And then your top is going to be 8i minus 6i squared. I squared is negative 1. Negative 1 times negative 6. Positive 6. 6 plus 8i. done. George. 16. Your clever one is going to be the conjugate. You got to times the top and bottom by 4 minus 2i. And then distribute that out through, and your bottom denominator should be a real number. And that is it.